David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you could turn on the captions and follow along with my words on the bottom of your screen. Today's topic, factoring trinomials. This is also called the product sum type of factoring, and I'll show you why in just a second. So a trinomial is just an expression with three terms. So this is a trinomial. It's also called a quadratic trinomial because it has a quadratic term, a term with a squared on it. So looking at this, you might go, that's factorable? And if you've never tried one of these, that looks awful strange. How could I write this as one thing times another? And the truth is, we can. So here's the thought process that goes through that. It might be a little confusing at first, but once you've practiced this, it's actually not so bad. So what we're doing is we're hunting for two integers. Remember, integers are no decimals or fractions. We need two integers that multiply to 6 to the last term and add up to the middle term, which in this case is 7. So two numbers that when you multiply them, they make 6, and when you add them, they make 7. So if you think about that, or if you've looked ahead a little bit on the board, you'll know that those numbers are 1 and 6. So when I do 1 times 6, I get 6, and when I do 1 plus 6, I get 7. So that fits this rule, and this is why we call it the product sum. This is the product right there, and this is the sum. So the next step is pretty straightforward. You just take these two numbers, 1 and 6, and you plug them into two binomials like that one. So x plus 1 times x plus 6. And that's the result. That is the factorized version of this expression. Now, if you're skeptical, you have a way to test this. So think for a minute. How might you test that this thing really is the same as that thing? Okay, if you thought, oh, I can FOIL that, you're right. So let's do that. Let's FOIL. First term, x times x, that's x squared. Outside term is 6x. Inside term, 1 times x is just x. Last is 1 times 6 is 6. Now we combine our middle terms, x squared plus 7x plus 6. Bammo, that worked. We just FOILed our factorized version, and we got back to where we started. So remember, factoring is reverse expansion. So we factored this expression, and we got to here. Now if I expand that expression, which is multiplying, I go back to there. Okay, I've got a bunch of examples for you. Okay, so I've got these 4, and then I got 4 more after that. So buckle your seatbelts, get ready to practice. I strongly urge you, once you get a feel for these, pause the video and give them a try. In fact, you could do that right now. Okay, let's take a look. Here we are. We need two numbers that multiply to 24 that add up to 11. What might those numbers be? How about 8 times 3? Because 8 times 3 is 24, and 8 plus 3 is 11. That's all we need. So now we just write x plus 8 times x plus 3. And we're done. If you're not sure, you could FOIL that, and if you do that correctly, you'll end up back here. Okay? So maybe this is starting to feel a little bit more easy for you. So if you're ready, pause the video and try that one. Okay, let's see how you did. Two numbers that multiply to 15 but add up to 8. Those numbers are 5 and 3, because 5 times 3 is 15, and 5 plus 3 equals 8. Okay? So then we just plug them in. 8 plus 5 times 8 plus 3. There you go. Okay, try that one. It's a little bit more tricky because I got a negative sign in there. Okay, let's see how you did. So I need two numbers that multiply to 3, but those same two numbers have to add up to -4. So that seems kind of weird But if you think about it, you might realize what those numbers are. You got it? Okay, what they are is -1 times -3. That ends up being +3. Negative times a negative is a positive. But -1 plus -3 does equal -4. So those are our two numbers. Then we just do x minus 1 times x minus 3. And we're done. Try that last one. Okay, so the way the problem's written is we need two numbers that multiply together to make +33, but when you add them, you get -14. What might that be? That would be -3 times -11. That's 33, but -3 plus -11, that equals -14. So that just gives us x minus 3 times x minus 11. Now I get this question a lot, so I'm going to give you guys an answer. It doesn't matter what order the binomials are in. I could write x plus 3 times x plus 8, same thing. On my tests or my quizzes, no points difference. You get full credit no matter which order you put the two binomials in. Action. Okay, let's do 4 more examples. If you want, you can pause the video right now and see if you can do all of them, or you could pause it one problem at a time. Okay, let's do that first one. Two numbers that multiply to -21 that add up to +4. That's going to be -7 times +3. That's 21. -7 plus 3 is -4. So that's going to give us x minus 7 times x plus 3. Okay? How about this one? Two numbers that multiply to -10 that add to -3. What are they? -5 times 2, because that's -10, and -5 plus 2, that's -3. Okay? So that gives us x minus 5 times x plus 2. Okay? Let's take a look at this one. A little harder, I think, maybe. Two numbers that multiply to -8 that add to -2. What might they be? Here's how that works. -4 times 2 equals -8. -4 plus 2 equals -2. Okay? So this gets us x minus 4 times x plus 2. Okay, try that last one. It's a little harder. Okay, that's a tricky one. I made it that way on purpose. Two numbers that multiply to -14 that add up to -9. Now you might have gone right away, oh, that's 2 and 7, because we can make 2 times 7 get us to 14, and we can make 2 and 7 get us to -9. But there's a problem. If we wanted to add up to -9, we would need -2 plus -7. That's -9. But -2 times -7 is +14. So 2 and 7 as negatives don't work. And if you try all the combinations of 2 and 7, you're not going to get there. And the 14 really only has these two factors, other than 1 in 14, and there's no way you're going to get a 9 with that. So this one is not factorable. Okay, so a word about that. You will occasionally see quadratic expressions, trinomials like these, that aren't factorable. So be ready for that. However, what I notice is that some students, when they get stuck, they just write not factorable. And it's not common. For my tests and my quizzes and in our exercises, almost all of them are factorable, except occasionally there's a not factorable one. So if you're doing a test or doing a homework assignment and you find out that you're writing not factorable by a lot of them, what it means is you're not finding the combinations that you can use to come up with two binomials times each other. Now that you've finished, write down any questions so you can bring them to our next class and get some help. Remember that you can always watch the video again to improve your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.